In this video, I'm going to show you the last step required to start a master-slave CAM relationship in a PLCopen project in the KAS IDE software. We've already, in previous videos, created a CAM profile and then called the MC-CAM-table-select function to prepare the CAM profile to be called. And now finally, we're going to call the MC-CAM-in function block to actually start the CAM profile. In the previous video, we added the MC-CAM-table-select function block and inputted the name of our CAM profile as well as the options that we wanted to the other available inputs. And we saved the integer output to a variable called CAM-table-ID, which we'll use in a second to feed into our CAM-in function block. The MC-CAM-in function block is located in the function block library in the same section as CAM-table-select, the profile subsection of the motion-PLCopen section. I'm going to drag and drop that out into a new network I created. I'm going to once again go with the default instance name and have that automatically be added to my dictionary. I'm going to go down the line and fill in all the inputs and a couple of the outputs that you may want to use. First off, we have an execute input, so that's shorthand for rising edge trigger. So I'm going to make a new Boolean variable called startCam. And when this variable goes from false to true, that's going to trigger this function block to execute, and it will start the camming relationship between the master and slave axes that we specify. I have a 2-axis project, and I'm going to designate axis 1 to be the master axis and axis 2 to be the slave. Now for the next 4 options, these pair with the offsets and the scaling parameters that you use when you created the CAM profile in the first place. I could go to the Project Explorer, right-click the profile, and look at the properties. I'm going to hard-code or enter these same values directly into the instance of MC-CAM-in, although for any of these you can make them variables or enter different values, and then you would still have the same shape of the CAM profile, but the X and Y axes may stretch or shift based on the different values that you're entering. Once again, I'm going to use the same values that I used when creating the profile. So that's going to be a master scaling of 720 and a master offset of 0, and a slave scaling of 10 with an offset of -5. Master offset 0, slave offset -5, and that's where the CAM profile will start on those axes. And the master scaling 720 degrees, so that's 2 revs of the master. The slave scaling is 10, so my slave axis I'm saying has some linear mechanics that for 10 user units. Now for start mode, if you're starting a brand new CAM profile, you will enter 0. The other option is recovery mode, so that's if you're recovering from an e-stop or some unexpected stop with the CAM-in function block. You can restart in the middle of your CAM profile, but for now I'm just going to go with the default 0 start mode. CAM-table-ID, this is where you need to enter an integer that comes from the output of the CAM-table-select function block. So I already had the variable called CAM-table-ID, which is the output of CAM-table-select. So this is now going to be the input to my MC-CAM-in function block. And buffer mode, all the PLCopen function motion function blocks have this input. I'm going to do 0, which is abort, meaning if there is an active move on the slave axis 2, that will be canceled, and it will instead start doing this CAM-in function right away. I'm not going to fill in all of these outputs. Outputs are optional with the KAS IDE software. I am going to enter a Boolean in-sync variable, create a new one, CAM in sync. So this variable will become true once the slave has accelerated and has started following the master. Also, I'm going to fill out an end of profile variable, end of CAM profile. This will designate once the master reaches the end of its specified range. And if you have a cyclic or repeating cam, you may not be able to see this variable go true with just the naked eye, because it will only be true for one EtherCAT cycle, and then you will restart the cam profile again. But if you do scope this or use it in your program, it will become true for at least one EtherCAT cycle once the master axis reaches the end of the cam. So this is used sometimes if people want to sometimes switch the cam. You oftentimes want to not do that in the middle of the cam profile, but wait to reach the end to either stop the cam profile or call MCUCam in again. Either switch a cam, or if you have offset or scaling inputs that are variables, you can recall MCUCam in and have it start the cam profile with different inputs or a different cam. Now that I've added my instance of MCUCam in and filled in all the inputs and the outputs that I desire to use, I'm ready to compile and download my project. I did have a successful compile, and I am using the simulator just so I can actually show you through this video how everything will work. So now that I have downloaded the project, I have to start it running on my simulator. And I'm going to go to the control panel first to enable both axes, and then I'm going to start a jog. I modified it so I only have to click it once. And if I go to the simulator, you'll see both axes are green for they're enabled, and axis 1, which is my master, is now jogging at a constant velocity. Now, the slave is not moving because I have to start or call the startCam Boolean variable, which I'm going to force true right in my ladder project. And I do see that the cam in sync variable is on, so that means that it should be activated. And if I go, I do see that axis 2 is following the master axis 1, and it is doing this specific profile. So over 2 revs of the master, the slave will end up doing 1 rev, and it won't do it at one constant velocity. It will go out a bit, and then back at a constant velocity, and then forward again. So let me demonstrate this. So at axis 1 is the master, it's going at a constant velocity, and axis 2 is going out and back sometimes, but if I see the position is increasing over time, so it is going in a positive direction, it's not always going back and stopping at the same place the cam starts. So that's a quick overview of how to implement camming in the PLCopen project in the KAS IDE software.